Chapter 5, Section 1, Fundamental Identities. So all of these identities we have talked about previously. We've talked about the reciprocal identities. Cotangent theta is the same as 1 over tangent. Secant is the same as 1 over cosine. And cosecant is the same as 1 over sine. We've also talked about these identities in the fact that tangent is sine over cosine. Cotangent is cosine over sine. And we've also talked about the Pythagoreans. So these are some identities that you need to keep in the back of your head, and they are also on the worksheet that I gave you. And then these are some that are new. These are just your negative angle identities. So no need to memorize these. Again, they are on your cheat sheet, your formula sheet. So basically what this is saying is, and I'm just going to show you how to read these. Sine of a negative theta. Basically, you have sine of a negative angle is the same as the negative sine of that same angle. So if you can picture with me, you know that the sine of a negative angle, you are rotating clockwise. And then remember if you take the unit circle and put it on an XY axis and you get the sine curve, well, when you do the sine of a negative angle with that negative rotation, what you're going to get is you're going to get the opposite of your original sine curve. So it's going to be the negative, the opposite of your original sine curve, and we know what that looks like from chapter 4. And so that will help you hopefully look at these. Cosine of a negative angle is the same as your basic cosine curve. Tangent of a negative angle is going to be the opposite of a tangent angle. And then cosecant of a negative angle is the same as negative cosecant angle of that angle. And then secant of a negative angle is the same as the secant curve. And so that's how you're going to read these. Okay, so each of the functions, tangent, cotangent, secant, and cosecant, can easily be expressed in terms of sine and or cosine. And so we often make substitutions to simplify expressions, and this is going to help us to simplify some trigonometric functions. To simplify an expression, the first thing we're going to do is we're going to write the expression in simpler terms or in terms of sine or cosine, whichever one is going to make things a little bit easier. And then we're going to remove the quotients if possible. So let's look at this one. It says to simplify tangent theta plus cotangent theta. Well, when I look at this one, I see tangent theta we know is the same as sine theta over cosine theta. And then cotangent theta is the same as cosine theta over sine theta. Now, it seems like we unsimplified that because now we have quotients. Well, remember the first thing we're going to do is write the expression in simpler terms or in terms of sine and cosine. So that's what we've done. Now, to simplify this, we need to combine these two fractions. And remember, to add fractions, you've got to have a common denominator. And so our common denominator is going to be cosine theta sine theta. It's just the two denominators multiplied together. So on the left-hand side, in order to get your denominator, this denominator, to look like this denominator, I had to multiply by sine theta. So on top, we're going to have to multiply the top and bottom by sine theta. And so on top, we're going to get sine theta times sine theta is sine squared theta. And then the one on the right, we have to multiply the top and the bottom by cosine theta. And so that's going to give us cosine squared theta over that common denominator. So now what I'm going to do is I'm going to make one fraction. So I'm going to have sine squared theta plus cosine squared theta over the common denominator of cosine theta sine theta. And so now what I have is I have one fraction. One fraction instead of two terms. I have one fraction. Well, I know that sine squared theta plus cosine squared theta is equal to 1. So I have 1 over cosine theta sine theta. And then we need to remove the quotients if possible. Well, what I can do is I can turn 1 over cosine theta into secant theta. And I can turn 1 over sine theta into cosecant theta. And so this would be our simplified. So what I did is I said 1 over cosine theta times 1 over sine theta. And you have to agree with me that 1 over cosine times 1 over sine is going to give me this here. But 1 over cosine theta will go to secant, and 1 over sine theta will go to cosecant. Okay, so let's look at this one. This is distributive property. We remember distributive property from algebra. And so one of two things can happen here, and it's completely and totally your choice. I know that 1 plus tangent square theta, that is a Pythagorean. And if I wanted to, I could go ahead and change that into secant square theta. So two options here. I'll work both of these. One, I can use the distributive property because that's what this slide is supposedly teaching. So you would have cotangent square theta plus cotangent square theta tangent squared theta. Well, that's going to give us cotangent square theta plus, when you multiply reciprocals together, that's going to give you 1. And then we know, again, from Pythagoreans that cotangent square theta plus 1 is the same as cosecant square theta. And again, that's your Pythagoreans. Or if you wanted to, you could take this and you could change them all into sines and cosines. And if you change them all into sines and cosines, you're still going to get cosecant square theta. The other thing that you could do is you could take this 1 plus tangent square theta and go ahead and use that Pythagorean and say cotangent square theta times secant squared theta. And then change these into cosines and sines. So that's going to be cosine over sine square theta. And then this one is going to be 1 over cosine square theta. And these two will cancel out when you multiply the two fractions, and you get 1 over sine square theta, which is the same as cosecant square theta. So you can see there's a bunch of different ways that you can go. It's just whatever comes to your mind. If the distributive property is what you see, then go for that. If you can't see that cotangent square theta and tangent square theta are reciprocals of each other, and when you multiply reciprocals you get 1, then go ahead and change it to cosine and sine and then multiply them out, and you'll get 1 anyway. Everything will cancel out to 1. So you take the route that you need to take. Okay, full method again. This is from algebra. So if we full this out, we're going to get first times first is going to be secant square theta, and then secant theta plus times 1 is going to be plus 1 secant theta, and then minus secant theta, and then minus 1. And so these two are going to cancel out, and so we get secant square theta minus 1. And again, that is going to be a Pythagorean. And so, and remember now, we can manipulate these Pythagoreans. So secant square theta minus 1 is the same as tangent square theta. And that answer is okay with me, because if you break it down to sines and cosines, that's going to give you that quotient back. So that answer would be good with me. So what Pythagorean did I use? Well, we have a Pythagorean that says tangent square theta plus 1 is equal to secant square theta. Well, if I minus 1 from both sides, I'm going to get tangent square theta is equal to secant square theta minus 1. And so that's where that comes from. Okay, so let's try to simplify this. when I look at this one, we know now one thing that I will caution you from is, just like we learned in algebra, if you have addition or subtraction on the numerator, you cannot cancel anything out unless you can cancel from both terms. So, for example, a common mistake is everybody will want to do sine theta over sine theta will cancel out and leave you with cosine theta, and you cannot do that. Not unless you can take a sine theta out of all of the terms. So what I can do is I can break this up into, because there's going to be a common denominator, of cosine theta over sine theta plus sine theta over sine theta. And again, that's just working backwards, because to get this, what we would have had to do is get a common denominator and then put everything together to make one fraction. Now I see that cosine theta equals cosine theta over sine theta is the same as cotangent theta. And then, of course, sine theta over sine theta is going to be 1. So you get cotangent theta plus 1. But that's not cotangent squared plus 1, so it's not your Pythagorean. It's just cotangent theta plus 1. And that's going to be simplified. Okay, so this is our full method again. So if I do the full method, secant times cosine, those are reciprocals, so that's going to give you 1. When you multiply reciprocals, that's going to give you 1. So we have secant theta times cosine theta is going to be 1. And then secant theta times negative sine theta is negative sine theta secant theta. Alright, and then if we do cosecant theta times cosine theta, that's going to give us plus cosecant theta cosine theta. And then cosecant times negative sine, that's going to be reciprocals, but this time I'm going to get negative 1 because positive times negative is going to be negative. And then the 1 and the negative 1, those are opposites, so that's going to go away. So watch this. If I have negative sine theta and I turn secant into 1 over cosine theta, and that is multiplication, plus 1 over sine theta times cosine theta, what I'm going to get is negative sine theta over cosine theta plus cosine theta over sine theta. And then if you want to get a common denominator, you can, but what I think I would like to do is I would like to go ahead and turn this into minus tangent theta plus cotangent theta. And if you wanted to, you could go ahead and get a common denominator. And if we get a common denominator, that's going to give us negative sine square theta plus cosine square theta. And you would think that that's going to be the Pythagorean, but it's not because of that negative sign. So there's nothing that you can do going that route. So that's going to be your answer right there. Okay, so for this one, what we're going to do is I think I'm going to use the Pythagoreans, because I know 1 plus tangent square theta is the same as secant square theta. And 1 plus cotangent square theta is the same as cosecant square theta. And then what I can do is I can use my quotient identities, and I can say that this is 1 over cosine square theta, and this one's going to be 1 over sine square theta. And then when I use my complex fraction, skin over guts, I'm going to get sine square theta over cosine square theta, and that's going to be tangent square theta. So that one cleans up really nicely. Okay, so this one we have our negative angle, and if you'll remember your identities, tangent of a negative theta is the same as negative tangent theta. We don't want to work with negative angles. When we have a negative angle and a positive angle, we want to try to get everything in terms of a positive angle. So tangent of a negative angle is the same as negative tangent of that angle over secant theta. So now what I can do is I can go ahead and turn this into sines and cosines and see how that works out. So negative tangent is going to be negative sine over cosine, and secant theta is going to be 1 over cosine. So if we do skin over guts, we're going to have negative sine theta cosine theta over cosine theta times 1 is going to be cosine theta. And so those are going to cancel out and you get negative sine theta. And if you remember that negative sine theta, if we go back to our negative angle, can be sine of negative theta. Alright, so I'd like you to try these numbers on page 205. If you have any questions, bring them into class.